Our best fit line will be the least squares regression line, LSR line. It's in the form y hat equals b sub 0 plus b sub 1x, where b sub 0 is the y-intercept and b sub 1 is the slope. Y hat implies the predicted y from whatever x is used in the LSR equation. Another name for the LSR line is the prediction line, predicting y values from x values. We'll be discussing these components in upcoming videos. For now, just remember that y hat is the predicted y from the LSR line. We discussed the three descriptors of the association between two variables. Correlation deals with all three of them. First, the term correlation only applies if the two variables have a linear association. Second, it assigns a numerical value to show how strong the points hold to a least squares regression line. Third, it will be positive or negative. We will learn in another video how to calculate the R value, the correlation coefficient. If the points are in a perfectly straight line, the R value will be 1 or negative 1. Positive if the LSR is positively sloped, and negative if the LSR line is negative. If there's no correlation, R equals 0, it means that the LSR line would be horizontal, slope equals 0, thus R equals 0. All of these scatter plots suggest a correlation coefficient of R equals 0. This means as x goes from small values to large values, there's no significant linear pattern in y value changes. The pattern could be nonlinear, but the y values are not consistently rising or consistently falling along a linear path for all x values, hence no correlation. No matter what value of x we consider to predict the corresponding y, our best predicted y remains the mean average of the y's. The mean y is called y bar. The scatter plot that tends to be horizontal does follow a horizontal line. However, the slope is 0, so there's no change in predicted y values no matter where we are in terms of the x value. Remember this for later. Horizontal line, no slope, thus no correlation, thus R equals 0. And therefore, the line of best fit is y hat equals y bar, meaning our predicted y will be the average value of the y coordinates no matter what the x coordinate is. Rarely in life would you see a scatter plot with R equals 1 or R equals negative 1 or even R equals 0. Typically it is somewhere in between due to random chance fluctuation of observed points about the line. The larger the spread of the observed points away from the LSR line, the less the strength, the accuracy of the prediction line, meaning the closer R gets to 0. The closer the points hold to the LSR line, the closer R is to 1, implying strong correlation. This plot has an R value of 0.8 and is considered strong. This one has a correlation coefficient of R equals negative 4 and is moderate correlation. This one has an R value of negative 0.06 and suggests basically no correlation. This has an R value of 0.98, very strong, positive, linear association, and since the association is linear, we can call it strong, positive, linear correlation. Beware, just because you may see a high R value does not necessarily imply a linear association and therefore does not imply correlation. For example, if a paired data set had an R value of 0.93, is it possible that it does not even have a linear relationship? The answer? Yep. You should always examine a scatter plot to verify linearity of the association between y and x before you declare that there is correlation.